All right, good morning. Let me go through each problem, see if you guys have any questions. Again, worksheets are up here if you want to pick up a copy. Okay, so a fire is spotted from the top of a 125-foot tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? Okay, we know we're dealing with the right triangle, so let me just go ahead and draw that. Okay, we talked about how angle of depression, we can treat it like angle of elevation, and but maybe a more specific way of saying it is that make sure wherever angle that you're creating, that there's always a horizontal. Okay, there's always a horizontal component when you're creating your angle. So we never want to create an angle where it's including a vertical portion of the triangle. You always want to include the horizontal portion. So I drew my triangle this way. Angle of depression is same thing as angle of elevation in terms of our problem here. So 19 is going to go in this spot, right? Okay, we have a top of a 125-foot tall fire tower. So fire tower is going to be that vertical portion of our triangle. Got a worksheet there if you want to pick one up. Say how far, it says how far is the fire from the base of the tower. So whenever I see the word base, I'm thinking about horizontal component, right? The bottom portion there. Okay, so what can we use here? To solve for x, sine, cosine, or tangent? Say it again? Tangent. Tangent, okay. Wait, yeah, tangent. Sorry, I messed up on my problem there. Number one is wrong here. So tangent 19 equals 5 over x. Cross multiply here. Okay, divide the tan 19 over to the right side. Is that what you guys got? Okay. Sorry. Okay, question with one. All right, number two. A radio station tower was built in two sections. So you got the radio station tower, you got the first section that's built, and then they started working on the second section. Okay. So from a point 87 feet from the base of the tower, so there's my 87 feet. The angle of elevation of the first section is 25 degrees. So this is where the construction stopped when they finished the first section, and then they finished and the completed section is going to be all the way up here. So angle of elevation to that first section is only 25 degrees. But then when they completed everything, then the angle of elevation to the very top is going to be 40 degrees. it says to the nearest foot, what is the height of the top section of the tower? So ultimately, I'm trying to figure out this piece. But as you guys have seen from the last quiz, this is the problem where we have to think of it as finding two separate sections and then subtracting to find that upper section. Because if you look at this upper section, this is not going to be a side of a right triangle. So we want to be able to use right triangles to help us eventually get to this. So, but we can create a right triangle with a bottom triangle. We can also create a triangle with the entire piece here. So the idea is, what if I can find z, which is going to be the height of the big triangle, and then I can find the height of the small triangle, which is y, and if I subtract those two, z minus y will give me that x. So I'm going to make it a little bit cleaner to look at by thinking of this as two separate triangles. So I'm going to just isolate the small triangle on this side, y 87, and the big triangle, z 40. Okay, looks like we use tangent for both of these, right? So I have this component. I have this lower component. So my target height is just the second section there. So if I do z minus y, I can get to that piece that I'm looking for. It says to the nearest foot, so I'll say 32 feet. I got worksheets up here if you want to pick up a copy. Okay, any questions with 2? Okay, number 3. This is the first year Janice is playing softball. She has been practicing her batting. On her last swing, the bat made an arc with a radius of 48 inches and swept through 255 degrees of rotation. Assuming the arc is circular, what is the distance of the tip of the bat? This is the tip of the bat travels to the nearest inch. So we know that the bat is going to travel in a circular path. We know this is dealing with arc length. Arc length. Okay, so we're going to be filling in information using arc length formula. Okay, so let's see, radius of 48 inches. So we have that. Swept through 255 degrees of rotation. We know that is relating to theta. And this, we're trying to find the distance, right? So we're trying to find that distance the bat travels. The tip of the bat is going to travel in a kind of circular path, right, as it swings. So we know that arc length is what we're looking for. We're looking for S. Now, are we ready to use this formula to plug in? Okay, what's wrong? Good. This theta is not in the appropriate unit. We have to get it in terms of radians. So we have to do some conversion here. Times pi over 180. .4505. Okay, so now this is in terms of radians. Now we can use this formula, right? So we have R, we have theta. Now we can solve for S. It says to the nearest inch. We're trying to get to the nearest inch, so we don't want to leave pi in the answer because then we are not quite. We basically want a decimal version first and then get to that value. I think this is, you only want to keep that pi if you're just converting from degrees to radians and I ask you to have an exact value, then you can just hold on to that pi. But here, word problems, we tend to want a more numeric answer, so we just have that pi built into that decimal to help us with our answer. Okay. Okay, first page. Okay, for those of you who came in late, I'll go back and show number 1 and 2 after I get to the back page. Okay, number 4. Order pair 5, -2 is a point on the terminal side of theta in standard form. Find the exact values of the trig functions of theta. So 5, -2, but if we plot that point, we know that's in the 4th quadrant. So over 5 down 2. Whenever you create a triangle, always have the x-axis as part of your side. Over 5 down -2. I'm going to find the hypotenuse using Pythagorean theorem, and then I can do all the trig ratios. Hey, good morning. Oh, I'm just doing a help session for Excel pre-cal, but you can sit, no problem. Okay, so sine theta, we can do SOHCAHTOA here. Opposite of hypotenuse. Let's rationalize our denominator there. Adjacent of hypotenuse. opposite over adjacent. Okay, cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay, any questions here? Okay, use the given information to determine sine, cosine, tangent of theta unless already given. So we're going to be creating triangles first, or at least finding our order pair before we find sine, cosine, and tangent. So tangent theta equals 5/3. Sine is less than 0, so you got positive tangent and negative sine. Which quadrant is that going to be in? Third quadrant, right? Tangent is positive, everything else is negative, sine is negative, that makes sense. Okay. Opposite over adjacent. So we're in the third quadrant, so we have to adjust our x's and y's, right? They're both going to be negative. Negative over negative is positive, so that's why we don't see a negative show up in tangent of theta equals 5/3. Okay, Pythagorean theorem, get that hypotenuse. Okay, question with part A. Okay, part B, secant of theta is undefined. We know that anytime we're talking about undefined, we're basically looking for zeros on the inner circle, right? So any place where there's a 0, that's the only place that we could potentially have any undefined if we were to flip that 0. So we know it's going to be one of the quadrant order pairs there. So secant is related to cosine, right? So cosine is the x value. So basically wherever cosine is 0 is going to be where secant is going to have its trouble. So that's going to be along the y-axis, right? Okay, so just think about that cosine of pi over 2 is 0, cosine of 3 pi over 2 is 0, but if I were to flip 0, I'll get undefined. So I'm looking at one of these two order pairs. But my interval is only between 0 and pi, so I'm only looking up to the second quadrant. So that means this 0, -1 is out. I'm only going to be using this order pair here. because of my my domain there. Okay, so everything is just going to be built off of this ordered pair. I want to find sine, cosine, and tangent. Sine is the y value, cosine is the x value, and tangent is y over x. Yes?
How did you determine it was the positive one?
Because the theta is between 0 and pi. So here's 0, here's pi. I'm only looking at my range of values in that interval. So if it were to say from pi to 2 pi, then I'm forced to have to use this. Yes?
Question is given in radians and how
Well, we don't have to deal with radians because we're only asking for the ratio. So it's not going to make a big difference in terms of our answer. It's just, but we do need to recognize that 0 to pi is talking about, same thing as 0 to 180. Yeah, but we don't have to. There's no degrees that we're trying to look for. So if it's just a ratio, it doesn't matter whether you have radians or degrees. Okay, so sine of theta. It's just the y value. Cosine is the x. What about the tangent? Yeah, 1 over 0, that's undefined. Y over x. Okay, part C. Sine is equal to 0. So let's see, sine, that's the y value, right? So sine equal to 0, that's going to be probably along the x-axis. So those are my two options, right? These are my two options where my y value is 0, but I want secant to be 1, so what am I looking at? Yeah, positive side, right? Secant is the reciprocal of cosine. If I were to take 1, and if I were to flip it, it will still be 1, so that's where I'm looking at. Sine, cosine, and tangent. Tangent is y over x. Okay, questions so far? Number 6, name the reference angle for 7 pi over 10. Now, just look at this fraction here. Just look at that 7/10. Where is that going to be? First, second, third, or fourth quadrant? All right, 7/10 is less than 1, right? Less than 1, but more than a half. So that's going to be second quadrant, right? Okay. And if you know that you're in the second quadrant, you know you have to, your reference angle is always going to involve the x-axis. So in this case, the closest x-axis is the 180 degree, or in this case, pi. We subtract those two. We can get a radian measure between 0 and pi over 2. Okay. Or common denominator. Three pi over 10 is less than 1/2 pi, or pi over 2. So you know that you have a measure that is between 0 and 90 degrees, or between 0 and pi over 2. Before we get to 7, 8, just want to point out cosine is undefined, never, right? This is, you're never going to find a place where cosine is undefined. I didn't mean to do that. You can change that to cotangent. Okay, cotangent is equal to negative root 3. You know that cotangent is x over y. So we're basically looking along the unit circle to see where we're going to get x over y to be root 3 over 1. So if I'm just looking in the first quadrant, just to get an idea, it's going to be at that pi over 6 line, right, where I get it's going to be a variation of pi over 6 because we know cotangent is x over y. If I were to cover up the denominator, x over y, root 3 over 1. This is not the correct quadrant because I want a negative, but I at least know what type, where to look. It's going to be part of this pi over 6 family. Or, sorry, I have to leave it in terms of degrees here, so 30-degree family here. So where is cotangent going to be negative? Quadrant what? 2 and? Well, cotangent is same thing as tangent in terms of their signs, right? So third quadrant, cotangent will be positive. So second and what? Fourth, yeah. So we want to find 30-degree variation. Of course, you can also just look on your unit circle. So what are my degree measures? Good, 150, 330. Okay, cotangent is undefined. We know cotangent is x over y. So basically, wherever that y is 0 is what's going to cause us issues. Yes, pi and 2 pi. But look at the theta I'm looking for, though. It's stretching all the way from 0 to 2 pi, and I'm including 0. So actually, I'm going to have 3 solutions here. 0, pi, 2 pi. Okay, cosine negative 13 pi over 4. We want to use our unit circle, but we want to get this into something that we can recognize. So we're going to keep adding. Remember, we can always add or subtract 2 pi or 360 to get it into that 0 to 2 pi range. Still not enough. I'll go add another 2 pi. You guys get that? 3 pi over 4. Okay. So now cosine of 3 pi over 4. We know that cosine is going to be negative in the second quadrant, so negative root 2 over 2. Again, you will have a blank unit circle on the test, so fill that out and you'll be able to reference it. Okay, 540. 540 is not within our range from 0 to 360, so I'm going to keep subtracting 360 until I get there. So it's just tangent of 180, right? Tangent is y over x, 0 over -1, which is 0. Okay, 19 pi over 6, that doesn't fall within my 0 to 2 pi range, so I'm going to subtract 2 pi until I get there. Common denominator. Okay, 7 pi over 6, that's in the third quadrant. I look at my order pair in the third quadrant there. I want cotangent being x over y, so x over y. So if I just cover up the denominator there, I get -√3 over -1, which is just √3. Okay, you guys get that for 11? All right, any questions on the back page? Yes.
How'd you find on 5B? How'd you like find where to how'd you like locate the current actions?
So, are you good with the options being 0, 1, and 0, -1? Okay. So if you look at the restriction here, it's going from 0 to pi. So that means I'm starting at 0 and I'm only going up to pi. I'm not looking at anything past pi because. So that's why I can't go to 3 pi over 2 because it doesn't extend for my domain. Okay, here's first page again for those of you who came in late, want to check your answers.